All right. So here we have two aircraft, A and B, flying with constant velocities in kilometers per hour with initial positions. Let's get this blue. With initial positions, A is at time equals 0 at position 4, -3, 2. The x-coordinate is 4, the y-coordinate is -3, and the z-coordinate is 2. With a velocity of, and it's heading -20 in the negative direction of x-coordinate, +30 in the positive direction of the y-coordinate, and then vertically at 4 kilometers per hour. B is a position -7, -6, 5, travelling at a velocity of 10, 20, and 6. Find when they're closest and what point the two rockets will be at. What point the two rockets will be at when they are closest. All right. So I'm not sure if you can visualize this. What I usually do is start off with a little scribble diagram where I put my locations. 4, I'll go across 4, I'll go back 3, I'll go up 2, and I'll make this little three-dimensional box here. Give me a sort of a reference of space, and I'll put A here. So A starts up 2 kilometers above the ground. It's back 3 kilometers, and it's to the right from the origin. I'll put the origin here at 0, at 2, at right 4. Now, let's just find, it's travelling, by the way, let's put point B. So point B is -6. So let's say 1, 2, 3, 4, 5, 6, -7, -6, and up 5. So it starts at a higher altitude. I make this little three-dimensional box here. And B starts in this position up here. Now, they're all sort of like kilometers apart. If we look at the directions they shoot off at, A shoots off at a -20 direction, like this way, +30 out this way, so -20, +30, with a Z of 4, and there's this little box here. Where are we? A will be heading towards this diagonal here. So we're going to be like shooting off in that direction. B heads in the opposite direction in the positive X. Right, so it heads out here. And it heads in a positive direction of Y also. They're both heading in the positive direction of Y. And they're both vertical, but it's going up at a higher. All right, so we've got this. B heads this way, straight through there. It's going up. So at some point in time, they're coming close to each other, but where will that happen? It's going to happen somewhere in this vicinity here, because A's shooting off up here, B's shooting off up in that direction. Now, what we're going to do to solve this is I'm going to make B's reference, let's B's reference still. Let's pretend that B is staying still. That means we're going to look at how A moves relative to B. So in mathematics, that is how A moves relative to B. The velocity of A relative to the velocity of B will be the velocity of A, take away the velocity of B. So that is, the velocity of A was -20 minus 10. So the velocity of A, which is, let's just write this down, negative 20, 34, negative 20, 34. Take away the velocity of B, 10, 26. Now this indicates that, can I move it? Yep. Negative 20, take away 10, that A is actually, if B stays still and just watches A is moving back at a negative 30 kilometers per hour. It's moving, the y coordinate is 30, take away 20, 30, take away 20. It's got a y relative of 10 kilometers per hour, and its vertical is 4, take away 6, negative 2. So it looks like that A is actually dropping because B is going up faster than A. So A looks like it's dropping. So B starts off higher, and it has a higher, B starts off at 5 and it has a faster vertical altitude. A starts at 2 and only has a vertical altitude of 4. So you see A looks like it's dropping down according to B. Now what we're going to do is leave B still and get the pathway from A in that direction of negative 30, 10, negative 2. And we're going to come up with this reference for, let's say, the line path that A will take. And that line will be at any point in time, because that's kilometers per hour, it'll start at a coordinate of 4, was it? A is 4, 4, negative 3, 2, right? So A starts at 4, and then it goes back 30 for every t, for every hour. And its y value, it starts at negative 3, and it's going to go, I don't want that comma, and it's going to go up 10 for every t, and it starts at a height of 2, and it's going to go back 2 for every t. Now that's the pathway for A, and what we're going to do is there's a position where with vectors, if you want to find out, let's just say this is the pathway for A, and B is still positioned somewhere. Now, as A goes past, there's a point somewhere here at right angles where there's some point here where they're at right angles. Now, with vectors, if you take this vector here and this vector here, and if you do a dot product, of this vector 1 with vector 2, vector 1 dot vector 2, if their dot product is 0, it means their angle is 90 degrees because it's a cos, there's a cos relationship in here, and cos of 90 is 0. And so we're going to take from B is at point 10, B is at negative 7, negative 6, 5. So let's take that point C. At some point in time, C is along that path, and at a particular time, that's point C. So what we're going to do is get vector BC and cross it with, we're going to get, we'll take this away, vector BC, and that would be that pathway minus B. So it's 4 minus 30t, take away negative 7. Don't want that bracket. negative 3 plus 10t, take away negative 6, and 2 minus 2t, take away 5. All right, that's the vector BC, which is, or CB in this case. No, BC, C minus B, yes. That is 11 take 30t, 3 plus 10t, negative 3 minus 2t. Now, if we dot with the pathway, now the pathway, because it's got a direction vector of, the direction vector is negative 30, 10, and negative 2. And that's the same as A, V, B. So we're going to go we're going to dot this. We're going to dot that BC with, and we want that to be 0 for them to be at the closest point. That means they are at 90 degrees between those vectors. So 11 take 30t. I don't want that bracket, I keep doing that. 3 plus 10t, negative 3 minus 2t. We will dot that with negative 30, 10, negative 2. And that represents that pathway vector, which is the direction vector. We want that to be 0. And here we go. Let's do that. So we got negative 330 plus 900t. That's that plus, we're dotting the two y's now. The product of 10 times 3 plus 10t, so 30 plus 100t plus, and now we dot the z's. Negative 3 minus 2t times negative 2, so that's positive 6 for t equals 0. All right, so we got negative 300, negative 294, 900 plus 100 plus 4, that's 1004. Solve that, 1004t equals 294. So that's the time when they will be at the closest. So the answer for part A is they're closest at time 294. What's that as a decimal? Let's just get that as a decimal. 0.2928. All right, so that's approximately 0.293 hours. B, what will those 2 points be at? Well, first of all, point A will, if it started at 4 and its velocity is negative 20, times time, and it started at a y-coordinate of negative 3, and its velocity was at 30, and it started at a height of 2, and its velocity was 4. That's the position of A. Quick calculation. Let's just turn these into decimals. 4 minus 20 times 294 divided by 1004. So that's at a position of negative 1.857 kilometers. Negative 3 plus 30 times 294, 1004. That's at a y coordinate of I'm not getting this 5.7848, so that's close enough to 5. And 2 plus 4 times 294 divided by 1004. That's at 3171. That's where A is at time equals 294 over 1004 hours. And B will be at, now B started at -7, -6, 5. -7, -6, 5. And it was travelling at a velocity of 10, 20, and 6. So 10, 20, and 6. And we want the time 294 over 1004, 294 over 1004, 294 over 1004. Let's find out where B will be. So -7 plus 10 times 294 over 1004. All right, that's -4.0717, and -6 plus 20 times 294 over 1004. That's at -0.143 kilometers. And 5 plus 6 times 2, 4 over 1004. And that is at 6.7569, close enough to 7 kilometers. All right. And that's the position of A and B at time 294 over 1004. Okay, I hope this has helped. Until I see you next time, stay happy.